Welcome to WAGO Energy Data Management. I want to show you the application Energy Data Management. And in the first few minutes, I want to talk about the target of this application, of this product, the typical application fields. A system overview. This is a solution and application for energy data logging and management. That means we want to collect various sources of energy data and log them as a CSV file or also in a database. Then there are possibilities to make few mathematical calculations or calculate typical energy efficiency indicators and so on. To know where the energy consumption is, how high, to protect the environment, and at the end of the day, you will save money with reduction of energy consumption. That is the target, the first target of this product, but it's not the only thing. A lot of people use this application not only for energy data management, they use them also to log typical product figures of machines or whatever. So it's in simple words, a big logging machine, but specialized for energy data. How to work with this product? It's not necessary to program. You can just configure over an HTML5 web-based visualization. You can configure everything. So you need just Chrome or Firefox or a kind of browser to get an access to this HTML5 web interface, and then you can configure everything. So no special software installation is necessary, no programming knowledge. It's very easy. For applications, what does it mean? So the first target is, the first on the left side, record energy data. And there are a lot of different sources for energy. We think at first, I think about electrical power consumption. That is standard, we know it from home. And electrician want to measure some kind of electrical power consumption. Then there could be also another energy source, gas, water, heat, whatever. And you can record nearly all physical values. Depends on your demand, on your project. And the next step is to log this recorded data in a database, in a CSV file, on an SD card, in the cloud, wherever. There are a lot of possibilities, and you're very flexible and can do that. The next step, if you want, you can use a small add-on with an additional license to visualize the energy data in a colorful, let's say, beautiful way. That is more interesting for the end user of this product. That means, an example, the manager of the production hall or the user of a building, a little bit like a facility manager who wants to know and see a nice chart to how high the consumption is. And then you can also react to the values. That means you can configure alarms or can react. Okay, if the power consumption in the last 15 minutes is getting too high, you switch off something, a machine or whatever. So you can react. This is a nice picture to show you what is possible. So on the bottom, you see the field or where the values comes from. So at first, it could be a value from Modbus TCP, at example, or UDP. So a power consumption measuring device, a meter from independent manufacturer measures something, power consumption or whatever. And we can collect the values over Modbus TCP or UDP. Modbus RDU is also supported, so over the serial interface. We can connect directly sensors and meters to WAGO modules A counter module is possible for pulse counters. We have typical analog inputs for a pressure or whatever. So typical for 0 to 10 volt, 4 to 20 milliamp, for RTD, and so on. Three-phase power measurement module is also supported, I think very often used. So just use few current transformers and then you can measure the power consumption over a WAGO module. M-bus meters are also supported. It's also very often used, especially in buildings. An ocean is supported. If you have a room operating panel, maybe in a meeting room or an office, and you want to log the temperature of this room, you can do it within an ocean room operating panel example. Yeah, that is what you can directly connect to the WAGO node. Also, BACnet is supported. You can't see a picture of BACnet because it's new since a few days. That means we can also collect BACnet data or BACnet IP and log them also from BACnet devices. And on the top, you see the interface to the how we can provide the logged data to the cloud, to an FTP database, SQL database, and so on. OPC-UA is supported, Modbus also. So there are a lot of interfaces are supported where you can use to collect the logged values and data from the controller. Here you see a short description over the protocols. OPC-UA is new, and all the others. MQTT is also very often used, and Modbus. I think these are the very often used. The hardware we use is normally a PFC200G2, a 750-8212, and there we can connect modules. Yeah, depends on your needs, which module you need. You can choose what you want to combine together. Or you can use also a panel, and it's just a picture of the controller. Or you use a TP600 that's also supported, and a new feature is that we also support a CC100. Our compact controllers are also supported since the latest release. Yeah, here you see all the possible modules. So that we have talked about a counter module, analog input modules, I think very often used and necessary to measure any kind of physical sensors, three-phase power measurement module, communication module, a serial interface for an ocean or Modbus RGU, and at the end module. Here's just a sample of often used modules for analog and digital signals. Power measurement modules, so there are a few different ones, depends on the current transformer. Yeah, you can see there's 3 different ones. You can use them directly from WAGO. Serial interface for Modbus RTU, M-bus master module for M-bus meters, and so on. Here's a sample and a picture how you can connect the transformers to the module. It's not interior Rogowski coils. Yeah, just a sample for this meeting here. It's not so important. Let's talk about the numbers. So you can log a lot of different values, depends on your needs. So serial interfaces, M-bus, RTU, whatever, and you can combine it how you want. So there are a lot of devices supported. At the end of the day, maximum is 100 data points. So that is the bottleneck. That means you can combine what you want together, but at the end, the 100 data points can be handled. additional 40 alarms, so you can react to the data points. You can also make virtual data points, so calculated mathematical energy or data points. Different logger, 10 logger now supported, so 10 different logger can you use. One for an SD card, the another one in the database, whatever. MySQL, InfluxDB is supported. This is just a sample how you can collect Modbus RTU devices. This is a sample with a WAGO Modbus RTU power measurement meter. But yeah, it's not a must to use a WAGO one, but I used as a sample a WAGO Modbus RTU meter. Modbus TCP is clear, I think. A lot of installations, they have existing meters, measure something since years and you want to log them, then you can just collect the values over Modbus TCP. MBUS is also possible with a 649 module. So per module you can use 40 meters or device addresses. You can use also 2 modules. Everything is possible. If in the future we will have more and more MBUS wireless, this will be also possible with additional device from relay to collect MBUS wireless, but I have never seen that in practice, so yeah, let's see what happens. This is a sample for an ocean. So if you use room operating panels with an ocean, you can collect them, but you need a thermocon antenna from Thermocon or from WAGO and connect them to the RS485 module, the 652. Yeah, that was in few words about the hardware and the target of this product, of this application. The next question is how we can work with this application. You can download this application for free from the WAGO download center. Yeah, there you can find the application, you can download it. Every application of WAGO, also EDM, Energy Data Management, can be used 30 days for free without license. But for permanent use, you need a license. You have to buy the license and download the license. Yeah, then you can download this software with a small tool, WAGO Upload. And therefore, I will recommend there is a YouTube video on the WAGO channel, how to install applications. Just 2 or 3 minutes, and then there is explained how to install an application on a controller. There is also a video available coding a license handling. So I will skip this here because there is a YouTube video on the WAGO channel on YouTube. Please look there. In my case, I have still everything installed. So let's take a look on the right side of me. The real hardware, you can see here, I have used here a normal PFC 200 G2 with an SD card for a logger. Application is running, is installed, the run LED is green. I have few digital in and outputs. This is a counter module, few analog inputs, serial interface for Modbus RTU. Here I have connected this 3-phase power transducer, Modbus RTU 3-phase power meter. This is our MID counter, the same like this one, but more modern, and it's an MID counter, not just for me. Then we have a MBUS master module where I have connect this MBUS meter just to show you how MBUS meters can be connected. Then I have 0 to 10 volt analog input. Here I have connected this display. Here with a potentiometer I can simulate 0 to 10 volt to show you something. And this is a 3-phase power measurement module. And here I measure the energy consumption of my training board here. So you see, I will show you so much as possible with real hardware to give you a real feeling about this product. Yeah, then let's go to the next step. I will go to the application. So here's the start page of my controller. I have installed the application, so everything is there. And this is the start page of the energy data management. I want to log in at first. So the standard username is admin and the password is WAGO from default, and I can log in. Okay, let's start with the inputs. So you see the application starts directly with the tab inputs. We have here two areas to collect data. So the first one is called inputs. Inputs means everything what is directly connected to the WAGO controller. All the modules I have shown you a few seconds ago. So digital inputs, analog inputs, power measurement modules, counter modules. Everything which comes from another field bus is located in field bus. There you find Modbus TCP, come on, Modbus TCP, RTU, NOcean, MBus, and BACnet IP. But we will start with inputs. So these are the two tabs where the values comes from, and then we can continue when we have configured few values to log them and to work with these values. That is our workflow. So let's start with the inputs. Digital inputs are automatically listed. So I have here installed a 60-channel digital input module, and this is automatically scanned and shown here. So I have 60 digital inputs here now. A digital input can be used, I will just use the first one as an example. So I just select the line or click on the line, configure or settings. This can be used as a normal contact mode, or we can use them as X-minute impulse. That means if you get a 50-minute pulse from your energy supplier, a lot of energy suppliers send every 50 minutes, for example, a rising edge, and then they measure the energy consumption. And if you want to react to this signal, an example, you want to measure your current consumption at every peak of this energy supplier, then you can just use the first digital input or digital input X-minute pulse, and every time, every second when a pulse comes onto these inputs, you can use this impulse later for calculating current consumption. You can give him a good name, 15-minute pulse, an example. Okay. And now I have one data point. Look here. Now at the tab DP, data point ID 1. So now I have 1 of 100 data points. Okay, that was an digital input. And every time when I change something or change anything in this application, you see the box here around this visualization is red. So that means I have changed something which is not saved. I can click here on the save button to save it. You can also, I will just do it. Okay, now everything is fine. You can use also an autosave mechanism. Therefore, I have to click on File, Project Settings, Autosave Interval. And you see from default it's 0, but you can type in something in milliseconds, how often you want to make an autosave. Okay, let's continue with analog inputs. Here a little bit more, because I have a lot of different analog inputs connected. So there is an RTD module like this, an example. Here I can connect, I want to configure. Let's say I can choose now the sensor type, because this module is there I can choose which RTD sensor I've connected. PT1000, that example, PT1, and this is in the unit is degree C, at example. Then it's automatically scaled and calculated to the right value. In my case, there is nothing connected, so yeah, you see nearly nothing. or the value is not correct, but it's just a sample. I think this is 0 to 10 volt input. This is 4 to 20 milliamp. And here on the bottom, there is an additional 0 to 10 volt analog input 2 channel. And here you see on the first channel of this module, there is a really value. This is, let's take a look, the real hardware, this module, and there I have connected this potentiometer. Now I want to scale it. Settings. Let's say I have connected to this device a 0 to 100 bar sensor. Then I can use here the calculator, and every analog module has a raw value. And the raw value of the 0 to 10 volt module is from 0 to 32,760. That can be found in the manual of this module. Then I want to scale it from this raw value to 0 to 100. And this mechanism calculates the gain automatically. I see this raw value and what I want to have at the end at the application value. The scaling is done. The unit can be changed. Bar. Oh, mistake. Pressure. Okay. And now you see it's scaled now. So 58 means 5.8 volt. So if I look here to the value, I want to do something with the potentiometer, go down, and you see the value is changing. It's nearly the same like you see here. Okay, now we have two analog inputs calculated or configured. Then we can continue with the power measurement modules. Here we have two possibilities. The 494, this is, the smaller power measurement module, and the 495, the bigger one. I have connected a 495. And you see this is the first one, and I see directly the values here, because you can have up to 20, and this WAGO module, and it's scanned automatically. So if you have more than one, you can click here to go to the next one. So I see the total active power now around about 20 watt. Yeah, it's nearly nothing because my small sample here has not a high consumption, but you see a real value. And if you want to log this value, and you can just click on add that example, then you get the value directly unscaled. So raw value is directly the value. In my case, it's okay because it's nearly nothing. In real application, it's much higher. So I will measure, oh, but the name is ugly. I will call them 495 power. Okay. Then I have, I want to log also the active energy here. It's in watt hours. And normally, if you have bigger power consumer, you want to have it in kilowatt hours or in megawatt hours. Then you can scale it here. Settings. Let's say I want to have them in kilowatt hours. So the unit is kilowatt hours. Then the gain is 0.001. 495 power. No, energy. No, now you see you get them in kilowatt hours. And that is now our fifth log value. Yeah, so that is very easy. The same like normal analog input modules. Counter module can be also logged. Let's use the first one. Counter, that could be, you can configure a unit. Let's say kilowatt hours. Preset value is start with 0 and multiplier is 1. That means one rising edge, is 1 kilowatt hour. And you can change also multiplier if it's more. So you look here, this is my counter module. I will use them, clonk, 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 clonk. And then I get a value. Something is wrong with my multiplier, but okay, I can change it if I want. Okay, but as a sample, that is enough. Okay, that was we have talked about the first inputs. Then let's continue with the field bus. I will save the configuration. Okay, here we have also 5 possibilities to get values over the field bus. Let's start with the first one, Modbus TCP. Oh, bucket configurator we need later. So Modbus TCP. So every device which is available over Modbus TCP or UDP can be configured here. So you add a channel. I can show you as a sample. Click on this channel settings and can configure a TCP or UDP connection to a specific device with an IP address, port number, and so on. Usually, as you know it, Modbus TCP and UDP. I want to skip it because I have here one Modbus TCP device, but this is a WAGO controller. So that is the second controller here on the bottom. I will use this controller as a Modbus TCP device and as a BACnet IP device. And therefore, I have a special possibility at Modbus TCP Remote I/O. So I can choose here 5 controllers. An example that is specially done for couplers. So if you want to collect something which is far away from your electrical cabinet, then you can install a Modbus TCP coupler and collect the values in few seconds. I will show you. So I can add the device or scan the network, but it's not recommended to do that. So 36, I think. Okay, I have now one device and click on connect. And now this device will be connected directly over Modbus TCP, and you see all the modules connected to this controller. And that is the controller on the bottom. And all the inputs of this controller or coupler are now listed in the tab inputs. Now I click on inputs, an example analog inputs. You see there is one additional analog input now available. Look here, with the slot 104, channel 1 and 2. And here I have also connected a 0 to 10 volt potentiometer, and I will lock them also. So I will just configure it. That could be, I will just show or lock the voltage. And configure the calculator from 0 to 10. Okay. Now I have 7 data points, and you see here the voltage. It's nearly the same like you see on this display. Yeah, this is not so not so good. It's not 3.14, but you can see if I turn the potentiometer, it is working. It's a live value. We'll go back to field bus. So that is the way how to connect Modbus TCP or UDP couplers. For all the other devices, use generic and create the communication manually. It is also possible to any device. Then let's continue with Modbus RTU. Here I have a serial interface where I have connected this power transducer, and I will now see the values of this device, and therefore I have to assign the field bus at first, because it could be, so I click on field bus assignment, that we have a lot of serial interfaces, and the application has to know on which serial interface which technology is used. For example, in Ocean or power transducer or MID counter and so on. And therefore I have to assign the serial interface to this technology or field bus communication. This is the onboard serial interface on the controller, and this is the first module where I have connected the power transducer. So I assign, oh, this is generic, be careful, Modbus generic, and for the three-phase power transducer and MID counter of WAGO, there are special tabs. Why? Because from WAGO devices we know exactly the baud rate and stop bits and so on, and there you have just to click on plus and then it's done. So to make it more comfortable for you, so I have a 3 PPT here, so I assign the 3 power transducer to this interface. Yes, choose the COM ID 1, and the slave ID of this device is 3, and now I can just add the device and that's it. And now you see directly values of this device. It's nearly nothing connected, but you see there are live values. And if you want to log this one at example, you can just click on add and you get the value, or with settings you can scale it, calculate it, and so on. But that looks nearly the same like the 495 module. The same for MID, the workflow is the same. Yeah, and in generic, there you can make connections to collect data from all other Modbus RTU devices except MID and 3PT of WAGO, because therefore everything is done and automatically. In Ocean, I have not connected an Ocean at this time, but you can do that. Just need a serial interface and connect an Ocean antenna, and then you the same field bus assignment in Ocean. Do you have a thermocon and Ocean antenna or the WAGO one? This is the WAGO antenna. Assign, and then you can configure it as select the COM ID, type in the Notion ID plus, and then the room operating panel is directly here, and you see the values and can log the values as usual. Then we can continue with MBus. Okay, MBus. Here I have to start to add a connector. So it is the first WAGO Modbus master module. First module. If you have more than one, you can choose them here. It could be possible that you have more than one. Then you have to make a connector for every module. But I will use the first one, just enable it. Okay, MBus is working. And I have connected there 2 MBus meters. I can add the meters manually or just scan the MBus field bus. Scan by primary or by secondary address. I will scan by primary address. And now you see I have electricity meter and a water meter. That's it. I can stop the scan, select all meters I want to use, and add the devices. Okay, now I have 2 meters here. Now I can configure also the meters here, how often I want to get a value. An example here is every hour. For most application, this default value is very useful, because if you collect data from an MBus meter, it's not recommended to do it too often. So every MBus meter has its own memory, and where the consumption is recorded, and you have normally just to take the values every hour, or it depends on your needs. Don't do that too often. So at example, if you have an MBus meter for heat, there is a small battery inside for energy consumption of this meter, and then it could be possible that if you read the value very often, the battery is low very quick. In my case, I have meters with a power connection, so I can use 5 seconds. And here also. Okay, every 5 seconds I get a telegram, and if you click on the meters, you see the meter values. So this is for water. If I want, I can change them to water. And this is electricity. Yeah, and then you can lock the values of this meter. For electricity, this one I want to lock, so I click on add, data point 9, and this one is data point 10. To see which values are configured at MBus, you can click here on analog data and see 2 MBus values. And if I want to show you does it work or not, I can here use the dip switches and do something, and after 5 seconds you see the values are rising, so it is working. Okay, that was MBus. So for every connector, 40 addresses where you can log the values. Okay, then let's continue with BACnet IP. That is new since this release, so very new. I work with a beta version that will be available in February 24 on the download server. And here I can also add a connector settings, and what is needed here is I have to type in the BACnet device ID of the device where I want to collect the values. And I have prepared something. The WAGO BACnet configurator is open, and I have connected here a controller, a BACnet device, this one, with the device ID 483275. Okay, 483275. 483275. Enable. Okay, looks that it works. Then I have a connection to this device and now can add a BACnet object. Let's configure. Let's say I want to use read analog input, the first one. That must be also a voltage. Present value. Every second, okay. Let's take a look. Is maybe the number wrong? 483. I make a mistake. Come on. Cancel. It is here. Settings 48. That's 6. It's 3. Wrong device ID. Now it's better. Now it works. So if I turn the potentiometer here, you see I get the value there. Yeah, it is working. And with add, I can add this data point to locked values. Okay. So that was BACnet IP. Yeah, that was in few steps the field bus and the inputs tab. So you see you have a lot of possibility to collect data. So physically data directly connected to the controller, allocated in inputs. I have shown you nearly everything. And field bus, everything comes from the field bus. So BACnet IP, Modbus, TCP, MBus, and so on. So now we have configured few data points. And all the data points are now listed in one list. I click on inputs, and here at process summary, you can see all these 11 data points I have configured. So you have a good overview here. All the data points. I will save. In the next step, I want to talk or show you the logger possibilities or logging possibilities. Logger. Let's talk about logger possibilities. So here on the tab logger, you can choose selective or define selective logger up to 10, where you can configure loggers for different types. So the first one, the default logger, is added by system. It's a local database, and all the data in this database are used later for the add-on visualization. So everything what you want to visualize at the end in this optional visualization must be located in this local database. But you can add additional logger. For example, I want to add a logger for SD card, so it's a CSV file. Setting, I will call them SD. SD, it is a CSV file. You can enable it. The write mode, one run mode is cyclic. You can also write at 90% of the filling buffer, because every logger has a filling buffer of 100 values. Because it's not very useful if you make a write access on the SD card too often. So every 5 seconds, you can configure at 90% filling buffer. That means it's not too often. So, but for my presentation, cyclic is very useful. Let's say maybe all 5 seconds. And what is new since this release is you can configure a weekly schedule for logging. That is additional now possible. So let's say log the values every Monday morning or whatever. You can configure it here. Typical weekly schedule. Okay. Parameter, I want to log them not on the home drive of the controller. I want to log them on the SD card. And this is located here. Home, now upper, media, and here is my SD card. It called them boot. You can select here a column separator and so on. Few options you have here also. Okay, an SD card logger is added. And you can configure up to 10 selective loggers, influx database is possible, MySQL, and so on. And there is a possibility to use a full logger. A full logger is very useful if you want to use this integrated and for free data logger to show data plotter, not data logger, to show the values in the graphical charts. I will just add a full logger. This full logger saves the values always on the only on the SD card. You see, it's the path and so on is directly connected or configured. You have just to enable this logger and how often, that's it. And now it's running. And this full logger logs, like the name says, full logger, all inputs. So all configured inputs, so 11 data points, are logged now in the full logger, additional to the selective logger. And this full logger can be shown as in a data plotter. I can show you. I click on File. Here must be a link to the data plotter. Information data logger. Yes, here. And in the new tab, the visualization data logger is open. This is for free and available. And here you can find the my log file. And here you can choose which values of this 11 you want to show. Now let's say this one and the color, apply, and now plop, you see the value. Now the voltage is nearly nothing, 3, the voltage is 250 and so on. And you can see that here. It's just a useful add-on and very quick way to visualize data. But this is only available for the full logger, for everything. A lot of people use this full logger additional to the other loggers to have one backup with everything, with the full logger. And on the SD card, there's normally enough space, so you can log them also there. Okay, I will just delete this logger because I don't need it anymore. Okay, now we have configured a few loggers, but you see, nothing is logged here. The logger is available, the logger is enabled, because no inputs are assigned to this logger. And that is what I have to do. Click on inputs. Let's say this pressure I want to log. So the second tab, logging. On the default logger example, that is very useful for the visualization later. Let's say every 2 seconds, or you can use also COV. Yeah, okay. And now you see this logger gets now every 2 seconds one value. That can be also logged there. 5 seconds is enough. This one can be logged also on the SD card every 5 seconds. Well, okay. This is the voltage. Can be also put to the SD card every 5 seconds. And so you can assign the data points. But in this process summary, you can only select one. So here's a multi-select is not working. So if you have, let's say you have a lot of MBUS values or 495 values, then you can make a multi-select if you choose this device at the inputs or where it's located. So here you can make a multi-select and click on settings and configure something. Or at inputs 495 for measurement. Here you can make a multi-select, settings, and configure the logging. It's possible. It's faster than to do everything here in the summary because here's only one at the same time, because different technologies can't be combined together. The window is different. Okay, but I want to log also this one. And this one also. So now I have 7 data points assigned to a logger, and all the others they are just configured but not used. Just to give you a sample. And now I change the view to logger, and here you can see the logger are working. So the buffer level is filling, and after a while, depends on your configuration, you have a write access to the database or to the SD card. So the logging is working. So now we have configured data we want to log, and we have defined where and how often we want to log the values. So that is maybe the first or the most important part, which every customer needs. Now we come to the special functions, alarms. Here you can react or react to a value or to work with these data points. So I click here on alarms and show you a few alarms. At first, I add an alarm and configure. We have here different alarm types. So alarm universal means an analog value where you can define a high and low limit, and if a high or low limit is reached, you get a message. I want to use the first one for the digital input. So let's say, and this is alarm hardware. No, alarm hardware means if something is wrong with the hardware, with the module. Alarm feedback failure. That is what I'm searching for. And I want to select the input. Let's take the first one. I call them 50-minute path, and the feedback reference is 0 with a delay of 1 second. Enable. Okay. Let's try. So everything is fine. I have no alarm because this input is off. I will switch on them. And not after a second, I get an alarm. I add an additional alarm. Let's use a universal alarm. I will take the pressure. It's from 0 to 100. Let's say the alarm is from 80. Low limit is not interesting. Deadband is also okay. Yeah, everything's fine. Enable. So the pressure must be this potentiometer. So 80 means 8 volt. Let's try 5, 6, 7, 8. Yeah, alarm limit high. No, if I go down and down 8, alarm is gone. Now I want to show you a very useful function. If you can't remember everything what I will show you, it is nearly not possible. And there are a lot of alarm types. You can click on a question mark here from every tab, from everywhere. And then what happens? In a new tab, the manual is open in the correct language and the correct page. That means I have a question coding alarms. So I clicked on this question mark from the tab alarms, and now I get an explanation of them. Here, show me the settings of alarms. Okay, and here are the description of all alarm types. Universal alarm, hardware alarm, and so on. And here you can see a description of all alarm types. Because you can't remember everything, it's not necessary. You can find it in the manual, but how many hours of your life did you lose with searching the right page on the manual? Here it's not necessary. Just click on the question mark here. So that means if you have a question for virtual objects, question mark, and there's explanation. So very quick. I will add an additional alarm, a third one. And just to show you, we have used now a universal alarm and a alarm feedback failure. There are a lot of other ones. Change of value. So if in a specific time the value changed too fast, you get an alarm. And here's also an alarm of alarms. Here you can combine alarms together. That means I can combine the first and the second one. So the first one, the second one, and if both alarms are active, and means what this and this one, you can make also or XOR. And I will call them super alarm. And if both alarms are active, the super alarm is active. See? If only one alarm is active, we have no alarm. But if both, we get an alarm. So you can react to the values. Let's say I want to show this super alarm at the electrical cabinet. There is maybe a red lamp, and I want that this red lamp is now flashing if something is wrong. Therefore, I can use an output. So I click here, digital outputs. Maybe I use the first one. Settings. Not permanent. 1 second pulsing. I want to show the status of an alarm. And super alarm. And here I can click on refresh, and then the name is also updated. And look here, if the super alarm is active, my first digital output is flashing. And there is a relay connected, so you see a lamp here and it's clicking. If the alarm is gone, no flashing. Again alarm, it's flashing. So if you have installed a red lamp maybe in your electrical, at the door of your electrical cabinet, then you get an error lamp. So I will switch off them. And this alarm can also be logged. Of course, it's normal data point, and you can log them. I have done here logging and can log how often or when this super alarm is comes up. And the next interesting thing is there is a possibility to enable a logger with a digital input. That can be useful. Let's say you have an SD card logger, and after a while you want to take the SD card out of the controller to download the values. Then you have to stop the SD card logger at first, otherwise you lose the data. Therefore, an input can be used. Digital inputs. Let's use this one. Not as a contact mode. Use it as a logger disable or enable. Selective logger SD card. That means if this input is true or enabled, the logger is active, and if it's disabled, the logger is not active. And then additional, I want to have feedback: is a logger active or not? That can be. So I will configure an output for that. Let's say the last one maybe. Permanent signal and show me now a logger state. SD card. Refresh the name. Clonk. And now you see the SD card logger is not working. The lamp is off. And with this input here, I can enable this logger. Now the SD card will be locked. It's shown here. And that is the way how you can disable a logger with an input, and a digital output with a status lamp can show you the state of this logger. Okay. Then we go to the next step, virtual objects. Here in the last step, you can make calculations with the measured data points. The first step is mathematical objects. Add an object, settings. Yeah, let's take a data point. So activate plus first line settings. I get an input. Let's say I have the pressure. I see here the live value. And add in another line where I can add two values together. Let's say pressure. Take the voltage. Okay, and I want calculate them together. So equal. The first line. You see, I have tried it a few minutes before. So here, $1 means first line, second line, and I will check this one. A simple calculation. I can type in a unit, or I configure a unit. Now you see they are added together. If you want to use a round function because you have too many digits here after decimal point, you can use the round function. Oh, my mistake. Here I have prepared clonk. So make a round function to this calculation with one digit after the decimal point. And now you have a really nice value and can log or do what you want with this value. If you want to know which mathematical options you have, you can click on this question mark and see here a formula help with a lot of typical mathematical calculation options. and where you can use it. A little bit like an Excel. If something is wrong with the value, so you see, okay, something in the calculation is is wrong, then you can click here on calculation steps, and then all the calculation steps are shown here, and then you can find where the failure is to modify your formula. Let's continue with energy objects. I think very often used are the typical energy objects. Let's take a look to the manual, what is written there. Settings, energy objects. Here's a list of all energy objects. So instantaneous power, that is typically very often used if you have a power consumption meter and you want to know the instantaneous power for the last let's say 15 minutes or hour. Delta energy divide by time since the last value change. Or the power mean value can be also used. There is a ready configured formula behind. So if you choose this energy object directly, the calculation will be done. And also a lot of other things. And they are described here. So it's not necessary to talk about every one because it depends on your application, on your project, what you need. Please look here in the manual. There's everything described. Right, example, just to give you a feeling. I get an input energy of this one, and I want to use X minutes mean power. That's the consumption. Let's say every 15 minutes. Then I can take the calculate them over my system time. That means the clock of the controller will be used, and every 15 minutes this value will be reset to 0. Or if you have an input as me, I have an input for the 50-minute pulse, then I can use directly this one. That means when the pulse from the energy supplier comes, this will set this mean power to 0, and now I have every 50 minutes the mean power of the last 50 minutes in this data point, and that can help to avoid loading peaks. For example, just a sample. So they have a lot of possibilities to do that, and that is then kilowatt. Because this is a kilowatt hour, this is kilowatt mean power. An example. And that can be also logged somewhere. And then you see, okay, from my last week, what was the mean power every 50 minutes? Is there a maximum, or did I have a load peak last week? In my case, it's 0 because, I don't have. You don't want to wait 50 minutes and there is nearly no consumer connected, so it's a little bit boring. But I think it's enough to show you how it works. Modem objects are only available for the controller with a SIM card 8217. I have only the 8212. Here you can add objects to log the signal status and so on, signal quality. Controller objects, let's take a look to the manual. Here you can configure minimum and maximum values. Here, drag pointer for max and min. That is clear, I think. So just to see what was the maximum value of the last week, last month, last year, whatever. Then you can configure this one. And accumulator objects, there are for typical sensors which measure a flow, and you want to calculate from this flow meter the mass flow, also the amount of water, whatever. Then you can use this objects for that. Per second, per minute, whatever. Look here. Liter per second. kilogram per hours, and so on. So you have here a lot of possibilities to work with the data points, to calculate them to energy object, individual mathematical objects, and the typical things like drag pointer and so on. And these are standard data points and can be logged as usable data points. Just additional possibilities we have here. Okay, I will save my configuration. Okay, I think now you have seen nearly everything. We talked about inputs and field buses, so where the values comes from. Then we talked how to log, how often and where. Then we have to work with them. We have an alarm configuration. We have status lamps, and I show you also the virtual objects. So in this application, everything is done. The next question is, how can I provide these values over a field bus to a SCADA tool or a database in my IT network or whatever? Someone wants to know or to get the data points somewhere located from this application over Ethernet. Which possibilities do we have? Therefore, I can click on File to show you that. So at first, cloud connectivity. Here you have a lot of possibilities. You can use a standard cloud service to send values to a cloud, WAGO cloud or other clouds. You can activate here MQTT. On the controller, there is a local broker if you want to use it. You can use also another broker and provide the values over MQTT, an IT protocol which is very often used. Yeah, here you can just enable it. Be careful for all the cloud connectivity things. You have to connect before it works. On the web-based management of the controller, you must establish the cloud connectivity. So I have just logged in just to show you in few steps how to do. Don't change the password. I get the failure message. Okay. Configuration, cloud connectivity. Here you have two connections where you can configure a connection to a cloud. Here you see I have configured days before native MQTT. It's one possibility, but you can connect also to a lot of other cloud services. Be careful when you configure everything. Don't forget to enable, submit, and then you have to reboot the controller otherwise the values don't take effect. And if it's done, you can check at status. Is the connection established, or is there a failure? Something is wrong. And if this is correct and the connection is working, you can go to the application and enable it, and then the values will be sent to MQTT or to a cloud. If you want to send value to a cloud, these values must be configured at outputs, virtual outputs, to the all cloud outputs here at outputs. All data points here will be sent to the cloud you configure at cloud connections. Yeah. MQTT can be decided or configured individually. So for every input at the data point, go to summary. Let's take this one, settings. Here you can configure the MQTT publisher. Normally it's not enabled, but you can configure it, and then this value will be sent to the over MQTT. Just a sample. And then you can use MQTT Explorer or whatever to show the values on MQTT. This is available since the first release of the EDM. Then you can send the values also over Modbus. Therefore, you have just enable the Modbus service here, download the outgoing data files, I can do that. Create the file. Then the Modbus server is active, and the SCADA software can get the values. You can just download now the created CSV file, and you give this Excel list to someone who's responsible for the SCADA tool, and he see directly the values, all the data points, the data type, and on which Modbus register the values are located, which function code is necessary, and so on. You get the information here. So Modbus TCP or UDP server. OPC UA is also implemented, is default active, so here you must do nothing. It's the data points are automatically on OPC UA visible. Yeah, that's it. So MQTT, cloud connection, Modbus TCP, OPC UA. That is 4 technologies to provide values to someone for SCADA or whatever. The backnet settings are only for the internal. That means not as a server. We have only a client. We use them to get values or data points to log into the WAGO controller and not the way out of the controller. Yeah, so be careful. This is just a client. We have not a backend server implemented here. Okay, so you see you have a lot of possibility to provide the values. Then I want just to show you, I will save. When I've configured everything and I want to make a backup of my configuration, can be done here at project settings. Here you can make a backup and a restore of everything. I think that is also useful at the end when you've done everything is saved. You want to make a backup, then you get I can do that, backup configuration. Then a tgz file will be downloaded, and with this backup file, I can restore my my configuration on a new controller every time, or make a copy to have a similar configuration for the next installation or whatever. And if you have a lot of data in your CSV file or on your database, here is an automatical cleanup available. That means for CSV files, I want to delete lines in my CSV file which are older than that means here, if I enable it, I can configure here, let's say 720 hours or something like this. That means every data in this CSV file older than 720 hours will be deleted. Or in a database, I want to delete data older than hours I can configure. So there is an automatic cleaning function implemented, because a lot of people, they don't care about cleaning the data. They collect everything over many years, and then they have so many data which are not necessary anymore. Then you can configure here as a cleaning method. Yeah, that's it. Here you see the license status. You see my application is licensed. The application is licensed, and I have an additional license called Visualization Energy Data Management. That is our last step. So the add-on Visualization Energy Data Management, which must be also licensed. Yeah. Information shows you the version. So you see I work with the beta version, which will be available soon. The number of the support is listed here, so you can see here every information. Okay, let's go to the last step, the add-on visualization. Maybe not everybody needs this add-on, but someone, I think, need it. It's a nice possibility to visualize with the colorful charts the logged values. Therefore, the license is installed. Okay, I have to click. I can go to visualization here, EDM visualization, or if I click on visualization settings, they have to look, is the visualization server active or not? Yeah, it's enabled. Okay, it's connected. Then I can have an access. The first step, I think, is to create an account. Oh, there is an account. Okay. I have done yesterday, I think. Yeah, okay. But normally, if there isn't an account, then you have to do in the first step, you have to create an account. But in my case, yeah, is I have done a account yesterday, so you can see that. Okay. Oh, you see here an alarm. The first alarm is active. Yeah, correct. You see, I am licensed because I see a picture here. Oh, I clicked here on the alarm to a link to the occurring alarm. But the target of this visualization is, in the first step, to show the measured values. Therefore, you can have here a dashboard and add a chart, and only values located or stored in the local database here can be shown. This one, default local database. Okay, I add a, oh, it's in German. Settings. So I want to change the language. I have to log off as first. And on the start page, I can change the language. So sorry for that. English. Nico. WAGO. It's still a German. Ah, I found my mistake. You can define for every profile a preferred language. And here at Nico, I have configured Deutsch. Please change to English. Oh, I have to type in my password. Ah, now it's in English. Okay. Dashboard 1. Add a chart. Title, pressure. Chart type line chart. Today. And here's a data point, the pressure example, in green. Okay, add. And now you see the values are there. And you can change here also, this is the value from today. You can change here, the time base. Plus minus is also available. You can download it as a JPEG, as a picture, whatever, a CSV file. A lot of possibilities. Let's use another chart. Energy. Line chart. Oh, I have only the power. Okay, power is also okay. Let's change the color. No. Yeah, you see the power is a little bit jumping. Oh. You can make also not only one value in one chart. You can use a lot of values in one chart. It's also possible. Or let's take a look here. Edit. Maybe let's take a look to how often we have super alarms in, let's say, red. No? And you see the time, how often we have super alarms and the power. So a lot of possibilities to make colorful charts to show the calculated configured data points to the end user. For example, facility manager of a building, you want just to have a chart, the energy consumption of last month or whatever, then you can configure it very quick and it looks nice. So a lot of possibilities to do. You can, this is one dashboard, you can use also more than one, a lot of dashboards, and therefore you have to go on your profile, settings, I think, dashboards, and here you can add dashboards here. Dash 2 example. And now you have 2 dashboards and so on, so you can make a lot of dashboards here. So for visualizing. But you can also see all the data points configured in the application here. So and when you click on summary, here are all my data points. So I have here the first 10 and the next page another 2. But be careful, you can configure and see the values of all data points configured. You can make changings here. So you, if it is example energy, okay. The logger CSV is not supported for the display. You see the energy is not located in the internal database on the SD card. That can't be used here. You see the data point, but you can't use it in the dashboard. That is why I said local database, only local database. Yeah? But you can configure the values here. So, for example, power measurement 495. You can make changing at this data points. Yeah? Edit, and you see here in the window, you can change everything the same like in the application. But I personally don't prefer that to do it here, because then you mix too much. I use this only as a visualization. That the first target of this add-on is to visualize, but the second one is also you can, if you want to configure a few things, maybe you define, okay, you create a chart, say, oh, scaling is not so good. Then you can just change the scaling here, yeah, and at the end apply the changings, and then it's downloaded to the database. And because the application visualization work with the same local database. But be careful, the complete commissioning, I will recommend to do it in the application and use this as a visualization tool. That's it. Yeah, that was in few minutes the application energy data management. I thank you for listening and watching. Please never forget the question mark here. It explains everything in the manual. And I hope this helps you also. And thank you. And I wish you all the best.